Okay, we're just going to go through how we can represent data as graphs. There's 4 we're going to do for discrete data. We'll do a little bit more with group data a day or so's time. The discrete data, they're things like where you count. You can't have half a house, half a television. So each of these values, you're either in none or you're in 1. There's no way to create another group in between them of half a television in a home. As opposed to the continuous data where you could actually measure how much time are you working at a computer or a TV, or how much downtime do you do at home. You could actually choose to do that every 15 minutes. You could count half hours. Technically, you could count minutes. You could count 30 seconds. So continuous data means you could smoothly move from one of these values to the other by going through lots of values in between. These ones, there's no value in between. You've either got no TVs, 1, 2, 3, 4. So that's my discrete data. Done a tally table, I've made a copy of the frequency, and the frequency in this case is talking about the number of houses that have that many televisions. So our first graph is going to be a pictograph. Now a pictograph is a simple representation, pictograph or pictogram. It's a simple representation that says for each number of TVs, we draw a picture next to it representing how many houses there were. So a sensible thing for me to do for this would be to use the number of houses represented by a house, not a television. We haven't got separate televisions, we've got houses going along here. Okay, so I'm going to use houses. We need to give a key. Now normally the keys are a house is one house is normally something more than 1. If you say it's 1, then you may as well just show the table or the tallies. But if we're doing these, we show 1 house, could be 2, it could be 5, it could be 10. Depends on how big your numbers are. We could be talking thousands. You'll often see in newspapers pictures representing the amount of oil, and that means that the amount of oil would be drawn as a barrel, and they'd be talking about hundreds of thousands of barrels per one big picture. Of a barrel would be hundreds of thousands of barrels being produced. That sort of what happens. So if we see half a house, we know that equals one TV, or one household with that many TVs. So to start with, top line, we've got 1 house which has no television. We then have 4 houses representing 1 television with 1 television. So 4 houses is 2 pictures. Moving on, we then do the next one, which is 7. So to get 7, I need to have 3 copies of a house. And that's 6, and we need 1 more for 7. And then on the house, that extra household is represented by half a picture of a house. 3, I need 9 houses represented, so that's 4 houses would give me 8, and half a house extra gives me the 9. And I need 3 houses for the 4, and I need 3 houses to represent 6 households. So I draw 3 houses to give me the 6, and the last one I draw 1 house and half a house to give me the 3. So now we've got these all shown. It's quite obvious to see we've got a most common size, therefore we have a mode. The modal group is there. It's the biggest grouping. And you'd have to actually read this out to say that there's 4 times the number in the key 2 plus 1 times the half. You'll only ever get one of these half ones. And that tells me that the mode is number 3 and the frequency is 9. But the mode is the data value. The next two graphs are actually very similar, and they're sort of variations on each other The pictogram, what you get shown, and we'll start off with a line graph, and I'll just convert it this time. So a line graph is either vertical or horizontal lines, not one of these dot patterns like this where you connect them up. That's continuous data and trend data. It is not drawing the line graph that we are looking for with discrete data. Because we can't have the halfway points, we can't go in between two places. So it's a line graph. So I need my axes. Make sure the axes are big enough that I can actually represent my numbers up to 9. It doesn't always have to be 1 square for one value. What you can do is actually have halfway points. Traditionally, the frequency goes up the side. So the frequency, and whenever you use the word frequency, I would recommend, what are you counting? Well, we're counting houses. Don't let the word frequency just take over. Make sure you know what the frequency is talking about. It's talking about houses. My data value is TVs. And that traditionally goes horizontally, although they can go vertically. So my frequency counts from 0, 2, 4, 6, 8 to 10. So I can fit my 9 in. With line graphs and discrete bar graphs, you do not label numeric data like this as if it was a scale. You give a tick mark in the middle and you say that's what that value is. So if these were colours, you do exactly the same thing. All discrete data give a tick mark and the data value that goes with it. And I'm going to put a 6 in here, even though it's not there. In a moment we'll talk about one other thing we can draw from these. So we now can draw in the lines. So we have one house that has no television. We have 4 houses originally. Yeah, it was 4 houses. 4 houses with 1. We have 7 houses which have 2. 9 houses with 3. 6 houses with 4. 3 houses with 5. And none with 6. Now that's the line graph version. Again, we can see the mode. We can also see that the minimum number of TVs in a household is 0, and our maximum from our survey is 5. Even though I have 6 here, it must have at least 1 household with that value. Otherwise you can ignore this value. And those two things combined mean I can calculate my range as being 5 minus 0, which is 5. Okay. Beyond that, we've got something which is called a bar chart, and that is a bar graph or frequency diagram. Collectively, these are frequency diagrams. So a bar chart is basically from the same thing. We start basically with the same idea, but now, rather than doing just a line, we create rectangles. But what's important for discrete data is they are not allowed to touch. Again, we must have this gap to make the difference between, there is no such thing as a value in between. So there's no such value as 1.5 TVs. Okay, so we don't represent values that can't be represented, and that's why the bars never touch. So the bars can never touch when we do this. There must be a gap. TVs. Last part for this is just quickly to introduce the exercise you've been set, which is this. When you're asked to plot these things, you're going to have to count the values. So if I thought that the people who got level 3s, if I said that there was one level 3, go to the box where it starts with the 3, go up the line in the middle, and if you click to the top of it, it will draw in a line for you. So this is, I'd say there's 5 people got a score of 4. Make sure you answer the question. Most pupils will be the longest line. And I think that's it. You need to do question 3 to 6, please. Okay.